I'm gonna get started here while Mike works on getting our screen shared. I'm Stephen Hodge. I'm the director of FREAC and also the Institute of Science and Public Affairs. I've been working in the GIS field since 1977, starting at a county level in Pinellas County, working for DOT, and the longest career is at FREAC. I have degrees in computer science and an MBA here from Florida State, and I've been with FREAC since 1984. Everybody see the screen okay?
Yes, sir, we can see it.
Okay, so you see the top, the names, those four names up there, that's our key players in the group here, with Georgianna and Beverly not participating in this presentation today. But here, this is kind of the overall what we're going to try to cover, just who we are, what kind of services we have, what kind of data and samples of our work. So how do we get started? So the legislature had some issues that they were facing back in the late 60s and early 70s, and that was, where does the state of Florida own land? If you look at the bottom row down there, you'll see that Florida's population was 6.7 million. So and now it's over 21 million. So we were a much smaller state back then, but there's still the problem of where does the state own land, and what kind of land do they own, and why do they own it? Also, the USGS was actively participating in building maps at the time, and was basically would go to states and say, where do you need help with mapping issues? And so FREAC was one of those places they came to where we would help them set priorities on how they were going to do maps. All the names that you see on probably 100% of USGS maps or federal maps comes from that GIS system there. So we help participate in that process of gathering that data back in the day, and so they would come to us to help them figure out where do they need to get started. The National Wetlands Inventory was starting at that time as well, and it came a little bit later. The ethyl dibromide problem was a situation where citrus was being sprayed with chemicals that were leaching into the water systems and known carcinogens, but where was all that happening? So we helped them get started with locating where that stuff was. So here's the kind of thumbnail sketch of FREAC and ISPA. FREAC is a member or a center within ISPA, and ISPA is an umbrella organization with about 10 or 12 different centers underneath it that I direct that do a lot of different things within the university community, from human rights to economic forecasting and analysis to early childhood development programs, just lots of different things. With FREAC is part of that. So FREAC is an applied research center. We provide technical assistance to government agencies as well as to private sectors. It's one of the main missions of the university is to connect the university to the general public, and that's one of the roles that centers like FREAC does, is kind of help make that happen. So we also train students. We have a number of students that will go through work on our projects, and that varies depending on the kind of work that we do, but our projects that we have at the time. You see the general areas of resource management, environmental analysis, but I want to point out, and you'll hear me say this a number of different times, our mission and our work varies greatly over the years, and as to who comes knocking on our door and say, can you help us with a problem? We don't always have the resources or the knowledge to do that, but we have the advantage of being able to reach into the university community and find people that can help us with that. Here's a list of a lot of the groups that we've worked with over the years. It's probably not a complete list, but you'll see that it varies greatly from private sector to federal government, and most of our work is done, of course, with the state of Florida. Point out this GIS Advisory Groups here. This next slide kind of shows you a history of what Florida has done as far as organizing GIS in the state. It's had a number of starts and stops along the way. FREAC has been a part of all these organizations over the years. helping in any kind of role that we had, as far as mostly in technical advisory positions, but we were on boards, all kinds of different things over the years. You will see the Florida Geographic Information Office, the 2018 to present. That's the recent version of what we do for organizing GIS in the state, and I would urge you to look in your agenda for tomorrow afternoon. I believe it is Kim Jackson will be presenting on that on that group and what they're doing in this coming year. We work a lot with water management districts over the years. So there's, again, some core strengths of some of the things that we work on, and I want to here's the second pitch here. If you don't see something that's in your bailiwick of what you need, that doesn't mean we can't help you. We can certainly look into the university community to find people that can, but those are some of the broad categories of places that we've done work and continue to do work in. Part of FREAC is something called the Florida Geographic Alliance, and it is a group that helps train teachers in middle and high school to use technology in the classroom, and specifically GIS. So you'll see just an example of one of their projects that they did in the past, where it was this is a great example of how technology has changed. This was something that middle school students did as a walking tour of Key West, and the interactive site will let you put your cursor over one of those dots, and up pops the pictures on the right with a little explanation. Well, that's a perfect story map. Okay, but that's what used to be is that strategy right there is what we made into basically a story map at the time. As part of FREAC, there is the Florida Natural Areas Inventory. I suspect that most of you have heard of them if you do any work in the environmental and forestry or categories like that, agriculture. This is a group that's in charge of collecting information to help preserve the biodiversity of the state of Florida. So they're constantly gathering information and analyzing information concerning natural areas and all of our environmental assets. You see the programs that have happened over the years that are land buying programs. Florida was one of the first in the nation to actually put up a website that kind of helped track where all the publicly owned lands were in the state of Florida. We've had some very aggressive programs in the past. Water management districts continue to buy land along the waterways and canals in their districts to, again, help preserve that. As of late, that's not necessarily going so well. We were putting in over $300 million a year buying land, but that's kind of tailed off over the last number of years. So here's a look at some of the current projects that we have underway. That land boundary information system is something that's been around for a long time, as well as the public lands inventory. Both those programs were born out of that problem that the state had back in the 70s and early 80s of where do we own land and how do we keep up with it. So those programs began in that stage. We worked with Department of Health with a number of projects you'll see here coming up. The College of Medicine, I don't have a slide in here about that, but it's a website that helped locate mental health resources in your area, which through the pandemic was quite a change in how we dealt with mental health issues. And this was a way of, specifically it was designed for young mothers to use, but it's really blossomed into something that anybody and everybody can use. Legislative reapportionment, we just finished a project on, and Michael's going to tell you a little bit about this resilient infrastructure later in the presentation, as well as one later this afternoon. So there's a quick history of Lavins. There's a lot of information on that screen right there, but to sum it up, there is that the state had information that land surveyors needed. The problem was that the information was in filing cabinets, people's desks, and things like that. So they came to us and said, how can we get this information out to the general public? So we started back in '84 of putting that information together in what you'll see down there is floppy disks and dial-ups, and I don't know if some of you on the phone probably won't recognize, or on the call won't recognize, that 300 baud stuff, because today, you know, we're dealing with super high speeds. Those are ants crawling right there. Floppy disks, again, I bet you some of you on the call here don't recognize those forms of data distribution. We started in '96 putting stuff up on the web, and that's been, of course, the answer ever since. So now what happened was DEP did not have to have people sitting at the ready at their phone to answer questions when surveyors said, I'm going to do a survey in this area, I need some help with locating control or whatever it is. They simply said, go to this website, look it up yourself, and if you got a question, we'll be there to help you. But it really saved them lots of time and money in the long run by just putting all that stuff online for them. There's an example of what a certified corner is. Familiar with the public land survey system? That's what we're talking about here. You can see that, you know, the next guy that has to go out and survey that southwest corner of section 26, he's going to have a very easy time relocating it because of that diagram that somebody's drawn there with very specific measurements and distance and calls and things like that. So again, it saves not only the guy who did this one, but the next guy, again, saves him quite a bit of time. What kind of data is in that system in Lavins? You see I want to point out that second bullet there, the GLO from 1824. These are the original records that the land surveyors used when they were laying out the public land system in the state. And so we have all their original maps and all their original field notes that they use to collect that stuff. And we get a lot of requests for that, or a lot of people who are using that to retrace original lines. There's original sales plats in there, how the land was transferred from the state out to the general public. The horizontal and vertical control from NGS, lots of water information, water boundary information. With sea level rise and affecting the state in quite a number of locations, this is going to become a more popular area, I'm sure. And then on the right side of that screen, you see a lot of the mapping data that we have. Now, some of that stuff you might look at and go, what would I need some of that stuff for? Well, a lot of this stuff now has become a little more historic than we might like to think here, because like the DLGs, the digital line graphs. Well, back in the day, that was the only way we had linear features on our maps, was to use these digital line graphs. Well, today you can go to tons and tons of different services and pull that stuff off. But these are some historic stuff. Again, if you need to look back at what did it look like in the day, there's a great resource that you can come to there. Lots and lots of imagery that you can get all the way back to 1995. We are housing all of the imagery that's collected in the state now. I think probably most of you know that every 3 years a county gets updated imagery. We have access to that. There's a geographic profile on there where you can type in some various small bits of information about where you are and be able to pull up what county, what state plane coordinate it is, just lots of different things there just to quickly identify your location. This is an example of that public lands inventory that we talked about. So there it's just color coded by federal, state, and municipal ownership. This is, of course, a shot near Tallahassee, and you see there's tons of public land in our area, and it's all owned by different entities, which is interesting to see in a very quick way. And you see the values. The state uses those values for various things. This information is really fed into another program called LITS at DEP that uses information for their internal purposes. There's the information about the Department of Health that we worked on. Many of you will remember the Zika virus issues that we had recently. Well, there's a map that we did for them to look at where the most populations are, that are most at risk. Economic hardship, walkability, other things that we've done that are health related. In some way, you might think, well, how's walkability health related? Well, part of the department's charge is to encourage healthy activities. Well, some places are more healthy than others when it comes to walking. So we help them identify some of those places. There's the reapportionment that's going on right now. You see it in the papers or online every day now. We've worked with the legislature, not just in those 3 years that you see there, but we go all the way back to 1970, where we've helped them with mapping and map distribution and analysis and all kinds of different things. Here's some projects that we've done in the past. That first one there, IMAP and Bases, was almost a 10-year program that involved hundreds of thousands of dollars, where we mapped invasive species. And I'll go through some of these in a little more detail as we walk through here. So there's a picture of what that invasive species project looked like. What I simply want to emphasize here, you don't try to read all that stuff, is that the systems that we develop can be as complex as requiring logins, and very complex analysis on the screen. This is all done with open source software, with the exception of some very basic map services from Esri, but almost all that is open source. So we don't always solve our problems or our customers' problems with out-of-the-box solutions. We often do it with customized programming. That was one we did with US Southcom, where the Caribbean nations are super vulnerable to natural disasters. And when natural disasters hit those small islands, government unrest can often happen. So we were helping to identify, what kind of impacts these storms might have, and how the government might be better prepared to handle those situations. I did not work on this particular project, but all the search and rescue activities in the state and federal use something called the U.S. National Grid, and that's an example of how you locate stuff by that grid. So being able to know what is in a grid is very resourceful. And if any of you have ever seen the devastation of Hurricane Andrew in South Florida, Hurricane Michael here recently, but not as dramatic, things get flattened and you can't really see what's going on, and the road signs are gone. So these grids help rescue teams identify where they're going and what they're perhaps looking for. Okay, so I'm now going to turn the talk over here to Michael Core. Michael's been with FREAC for a little over, well, almost 2 years now, and I'll let him introduce himself.
Good afternoon, everyone. Thank you for joining us today. My name is Mike Core. I'm an application developer designer at FREAC. We work on creating geospatial solutions and geospatial database solutions to complex problems. We try to put everything up on the web. It's a general theme that we do, is to try to make data more accessible and easier to use. So this project that we see right here was a multi-stage analysis for the Wakulla Springs Alliance. We were looking at a wastewater site. There was argument over whether or not this karst topography existed on the site. So we did several maps to kind of analyze the different area. We started off with some FEMA firm, which you can see behind there. Then we moved on to a more complex analysis, which is called the Topographic Wetness Index, and we mix that with elevation. That's a general count of the wetness of the soil. It also takes into effect like incline and slope and elevation. So we also compared that with some historical photages of the area, going back to see if this landscape did have these formations on here, for 20 or 30 years. Another aspect of the study that we looked at was we did some inverse distance weighting on the well depths, so we could get an idea of the water table in the location. So we put all this together and we made it available for the Wakulla Springs Alliance, and then we also gave a few talks about it and made the presentation available for them. Continuing, one of the things that we're looking into using that I've used in some of my recent studies is what's called Bayesian analysis. Bayesian theorem is a general expression for finding conditional probabilities. It was developed in the 1700s. It's an alternative to using regression lines and p-scores that gives a better relationship between variables, and it gives more information. A few problems with p-scores is that a p-value of 0.01 does not mean a 99% chance of a relationship. P-values actually is a rejection of your null hypothesis, where the low p-value is the chance of observing the data if null hypothesis is true. So a p-value of 0.01 actually means that there's a 1 in 100 chance of seeing an observation if the variables were unrelated. Many people mistake that into thinking that a p-value of 0.01 means 99% chance of the relationship, which is completely wrong. Another limit of p-values and regression lines is that it does not account for multiple values or the actual risk of the situation. When using regression to look at temperature and traffic fatalities, it appears that temperature has an impact on traffic fatalities, and your findings of your research would support that. Unfortunately, the reality of the risk of a traffic accident is much greater than just temperature. And using complex networks like Bayesian analysis, we can put those observations together to form a better understanding of the situation. Here's an example of how we used spatially informed Bayesian analysis to analyze Hurricane Michael impacts on Tallahassee. We used the Bayesian, we used satellite-derived vegetation indexes to gauge vegetation density around the built environment in Tallahassee. We also looked at nighttime light projections through NASA's Black Marble product to gauge the impact of nighttime light reduction from the normal amount. We also used the NLCD classification and classified the land types inside of each grid square. So we were able to take all this information and compute it into a Bayesian network, which gives us posterior probabilities. If you look at the tables here, you'll notice each one is a histogram table. It shows the relationship between all of our variables that were in the grid format. So this specific arrangement shows the cases where the property had deciduous forests, and it also had a pretty decent number of NDVI near buildings. So we can see here at the middle percent of normal nighttime lights that the percentage of nighttime lights is close to 100% of normal. And this is one of the interesting phenomena that we found in the study. Another interesting phenomenon is that when buildings are near electric substations, there's an overwhelming decrease in significant power outages. This analysis will be published as Lights Out After Hurricane Michael, the spatially informed Bayesian network analysis of power outages in Southern Geographer here in 2022. So here is some analysis that we did to look at sea level rise and the sea level rise impacts for Wakulla County. We took in multiple data sets, including NOAA's DEMs that represent sea level rise. We looked at the American Army Corps of Engineers sea level curve calculator and took the measurements for low, int, and high induation based on the ACE's suggestion. And then we calculated each of those ranges. And then we used the digital elevation models to pull out each of those elevation ranges. We then went back and took the mean high watermark data to fill in no data values and missing 0 elevation data from the NOAA DEMs. Afterwards, we were able to intersect the DEMs with the parcel layers to get an idea of which parcels inside of the county would be affected by which levels of sea level rise. Here we can see that the blue parcels would be affected by the low, teal parcels are affected by intermediate, and then orange parcels would be the ones affected by the high levels of sea level rise. We were also able to intersect social vulnerabilities with population to get an idea of where the population exists inside of the landscape in comparison to the 4 metrics of vulnerability you see below: social, economic, household, ethnicity, and transportation. This gives us an idea of where the people are located inside of the county and what the community makeup of these people are in relation to the sea level rise. We are also able to get the property valuation in today's just value from the property appraiser just by doing a summation of all the parcels affected. On the low end, there will be $200 million worth of just land value affected. On the high end, it could be just over 3 million. Here's another example of bivariant mapping. Bivariant mapping is a technique to show multiple variables through one map layer. It's useful to show complex ideas very quickly and simply without having to go back and forth between different map layers. So what we have here is an analysis done by Dr. Strode, which looks at public and private drinking water and wastewater. It takes the population of the area and we look at population densities on a scale of a 1 kilometer grid, and then we filter the access to the water type through our population grid. That way we get an accurate estimate of who is using which types of water and where, versus just having a ubiquitous polygon that may cover an entire usage area or connectivity area. It's much better detail than just a county or zip code type analysis. Getting into some of the data, this is another study done by Dr. Strode. This is diametric parcel population mapping. Many situations, population mapping is done kind of from a top-up technique where you take the population for a wide area and you try to break it down into smaller groups. This study actually does the reverse, where we start with the parcels and we work our way up through group quarters to census data. So we try to get an accurate estimation of where everybody's living on the parcel level, and we can kind of see this throughout the map with the green dots. Larger green dots are representing a greater number of people living in that area. Here's an example of a web-based platform that we built that shows the walkability information. This is the Community Health Explorer that Stephen mentioned earlier. The specific information is the walkability. It allows us to see disparities between areas. We can see how Gainesville has a very dense location of walkability here, where Jacksonville only has, small densities of walkability, and Tallahassee has fewer yet still. Other data sets that you can explore in our Community Health Explorer would be the Zika, as well as the economic hardship indicators. These are very useful data sets for decision makers. It brings together a lot of different sources into one spot that's convenient. Here's another example of bivariant mapping. It's a study done by Dr. Strode. It's where we consider social vulnerability through the lens of population. Generally, census data breaks down social vulnerability and CDC data into larger tract or zip code or county areas, as we can see in the left-hand map, which is the standard way that everyone is used to seeing this data. Well, when we take that same univariate data set of just social vulnerability, and then we filter it through the lens of population using the US National Grid 1 kilometer grid squares, as well as the population counts from WorldPop, we end up with a much better view of the areas that social vulnerability is actually impacting. It filters out a lot of the empty areas like the Ocilla and Okefenokee National Forest and Swamp area, which would be located, around here. It looks like that is one of the most vulnerable areas on the map, when in actuality it's actually swampland, and there's very few communities within inside of there that would be considered vulnerable. Continuing into the more social vulnerability, here's another project done by Dr. Strode. This is called social vulnerability multivariant glyph map. The idea is to take the 4 separate CDC social vulnerability maps and combine them into one functional glyph map that also considers population. So as you see here on the left-hand side, again, we have fairly ubiquitous areas that would make it appear where some areas are in higher risk than others. Well, when we take the same data sets and filter it by the population, and then we combine all 4 data sets into one layer, we can get a better idea of where the people are actually living. And then very quickly, we can look at the proportional symbol size and gauge how many individuals in that population fall into that vulnerability metrics in relationship to the Florida population count. Down here at the bottom, we can see the separate sizes of the vulnerability indexes. Here's another example of bivariant mapping. This example shows land use and land cover. It's another study done by Dr. Strode. This one is an experiment with out-of-the-box mapping. It's just to use the U.S. national grid with other data sets to make more spontaneous or more eye-popping visual colors. It allows more information to be seen quickly. So we have a lot of data that's generally shared amongst many data sets shown very quickly. And once you get familiar with the legend, it's very easy to use. There's a project that I worked on. This was called the SARTOPO project. We did not create SARTOPO or CalTOPO. This is simply a search and rescue layer that can be used via the web. We decided to go with SARTOPO because it was suggested with us, but the layer is actually a web map service that can be used through SARTOPO, GIS Surfer, ArcMap, ArcGIS Online, ArcGIS Pro. Basically, all you have to do is feed in the web map service and you'll have access to free, high-resolution population data for the entire Southeast United States. It's at a scale of 1 kilometer, and it uses a U.S. national grid. It uses world population counts from 2020, and then so it considers a constrained environment. So it's not putting population inside of water bodies or gulfs or anything like that. This type of data is very useful for search and rescuers on the ground. As Stephen mentioned earlier, the U.S. National Grid is very important for search and rescue officers. It is the language of location for FEMA search and rescue, and it is the FEMA mandate and FGDL mandate for search and rescue missions. Here's another example of the behind the scenes of the SARTOPO project. So you can see the MXD that runs the MSD. Here's an example of all the states that we have done so far. We plan on getting the Northeast done next, since their coastline is also experiencing an increase in devastating storms. So here is the URL for the map service. If you just take that URL and put it into any type of web-based map viewer that supports web map services, it'll just pop right on up and you'll be able to use these data sets. Here's a little tease. Some of the information that we previously covered, including the sea level rise and inundated parcels, went into creating a resilient infrastructure story map. This is basically the pilot for an upcoming project that we're going to do, where we start with the campus and creating platforms that helps build resilient infrastructure and reduce greenhouse gas emissions through infrastructure and capital upgrades to things like heat pumps and other major assets, as well as it'll look at ages of buildings and other infrastructure that's important in the wake of natural disasters and climate change. So the web link below is active. It's good to go. If you just put that into the URL, you can look at the story map and play with all the maps and everything. We will cover this in my presentation here in about an hour and a half. I'll show it.
Okay, so thank you, Mike. That was a great look at what we've been doing lately. I want to follow up with just a few things here. One of the things that that I was noticing when we were going through all those slides is that there's a lot of different ways to display data that's not in what you call the traditional choropleth maps that you often see with GIS analysis. So want to encourage you to look at these things in more detail and see how they might be able to fit with your organization. You see there where you can get to our data. You can see where our map services are there. Some of this kind of work we do. And what's important here to think about is that just because you don't see something on that list that says, oh, that's the kind of stuff that I'm looking for, you may have something that's completely different than what you've seen or heard about today. That doesn't mean we can't help you, because as I said before, we often hire students to come work on these projects, and we can get them from all kinds of different departments. We also have professors that we work with. So again, I would encourage you, if you've got a problem that you're facing or need some extra help with, by all means, let us know. We will put this presentation on our website for you to look at. You'll see there's the contacts for all of us. The one there, the top one, just freac.fsu.edu. I've not put it up there, but we'll get it up there before the week's over, and an obvious place for you to see. Not all our projects are funded. You heard Dr. Strode's name used a lot there. Not all those projects that you saw were things that people came to us and said, hey, can you help us with this? Some of the things that we do are just kind of like experimental to see what we can do. And so if you've got something like that you want to explore, by all means, let us know. We may be able to help you. And finally, I'll say, reach out to us if you've got need some help. Our projects range from a couple $100, or I should say they range from free to hundreds of thousands of dollars. So we work all through the gambit. Lots of times people just need a little advice on something, especially with agencies that don't do GIS. We often talk with. Again, reach out and we'd be glad to talk with you and try to help you. So with that, we'll see if we've got any questions.
Thank you, gentlemen. Right now, it seems like we've got 4 comments. A couple of people have asked to take a closer look at the public-private drinking water maps, and they complimented you on that. The links to that will be on your website, correct?
Yeah, well, I'll put it up on that freac.fsu.edu. Again, I'll put it in some obvious spot where you'll be able to find it to look at that in more detail. And if you have questions about it that don't get answered just by simply looking at that, reach out to us and we'll get you in touch with either the agency we work with there, or we may be able to answer those questions as well.
Philip Griffin also complimented you, said awesome stuff. And then Richard Green said he noticed that on one of your slides it said Florida Geological Society, and it should be Florida Geological Survey. So he wanted to pass that along.
Okay.
And then Elke Urson said, FYI, the wastewater data set is housed at DOH.
Right. Okay. Thank you.
That's all the questions that we have at this point. So if you guys have questions, please go ahead and put them in the question box.
So maybe while we're waiting there again, I'll just say that what you see here is a lot of different ways to display data, and the population in Florida is not slowing down. It's going to be tremendously increased over the next few decades, and how that impacts our natural communities and our natural resources is going to be extremely important to keep up with. And a lot of the people that we work with are right on top of that kind of stuff, and we'd love to help them with managing that issue and helping get this kind of information in front of decision makers, because that's where the real key pieces are to be able to, it doesn't do us any good for us all around here to pat ourselves on the back and look at this stuff. It really needs to get to the right people to say, oh, we really got a problem here. Let's start addressing it. But it does start with analyzing data in creative ways, and I think that we're well on to some of that.
Ladies and gentlemen, we still have about 3 minutes left in the presentation, so if you have any questions, please go ahead and put them in the chat. We just got another one. Will day metric population maps from the 2020 census be available?
Oh, well, the daysymmetric maps for 2020 census population. Yeah, Dr. Strode and I were just talking about that we need to go through and upgrade all of our analysis with the new census 2020 data because it's just rolled out. So yeah, that is on the agenda to do, is to go ahead and start updating some of this analysis with the newest versions.
Yeah, and one of the things that we've talked about doing here, we just haven't got a good strategy yet, is how do you, the census data is great right now because it's current, but 2-3 years from now, it's not all that good anymore. So what do you do in those interim years? So we've been trying to entice somebody to help us get traction on doing those mid-year or mid-census calculations. I know there's places out there, Beaver at UF does that to some extent, but it's really not to the fine grain that a lot of you guys need in your analysis. So it's population is, again, it's going to, Florida has right now over 6% of the U.S. population, and that's just going to continue to grow as time goes here.
Well, if there are no more questions, thank you, gentlemen, for partaking and presenting in the 2021 Shrug workshop.